this is in preparation for a course, or rather from an introduction session for people to learn Unity. So I've decided to create this game, like a bricks falling game, where basically you control a little ball and then you move left and right, and you try to avoid the bricks falling down on you. All right, so that's a simple version of the game. So right now, let's see what we can do. This is our new scene that we have created. This is the camera. Okay, so right now there's nothing at the back. It's a blue background. It's fine. We can just use the blue background for the game. So over here, the hierarchy, we can see like all the different items to select. Okay, this is like a folder. Okay, this folder is to contain like your scenes. Okay, you can also contain other stuff like music and everything. So firstly, let us create a folder for scripts. Okay, because we will need some scripts later. We also create a folder for prefabs. Okay, which will be template things that you reproduce and recreate again through the game. Okay, so firstly, what we should do here is that, okay, so over here at the top, you will see different tools you can use. Like you can move an object. Okay, you can use the hand to grab an object. You can rotate. You can scale, rectangle too, and you can do everything. So this corresponds to Q R W E R T Y. I think this cannot be selected. Yeah. So these are different things that can be done. But first thing first, we can go to 2D objects. Okay, we can go to the 2D object. Create maybe a, let's see, a square perhaps. Okay, so we call this the ground. Okay, we call this the ground. Okay, let's not put this in the main camera. Okay, the main camera should be separate. Okay, and then the ground. Where's my ground? Okay, we can zoom in and zoom out using the like arrow keys. I'm using my mouse and zooming in and zooming out here. So let's say the ground it's say blue color. No, it's not going to be blue because the maybe yellow. Yeah, the ground is yellow color. Okay, and then I use the T tool, which is the rectangle tool, to do some scaling. Okay, so what I can do is like this. I can scale this rectangle like that. Okay, so this is like the ground where I need to control my ball. Okay, so this will be the ground. Okay, so if you view in the game view, you see this is the ground already shown here. Okay, let us do a little more like that. Extend the ground a bit. Okay, and then this ground, I'll add this component called rigid body 2D. Okay, rigid body 2D. If I set dynamic or kinematic, okay, they will typically have gravity acting on them. So we should normally just set it as static. Okay, static means that it will be fixed in that position. Okay, without any gravity acting on them. So that's my ground. Okay, I can duplicate my ground. Okay, and then I can probably call this thing. I rename this to be the walls. Okay, and this walls is a little different from the ground in the sense that these walls are at the side of the screen of the screen. Okay, to just prevent you from uh, from exiting the scene. Okay, so I have one wall here. I duplicate the wall. I have another wall here. Okay, so it is a good idea. Okay, let's before since we are going to use the wall more than once, we can drag it to the prefabs folder, and this will duplicate the wall again. Okay, so let's then use the prefab itself. Okay, to create the other wall like that. Okay, so this has a rigid body as well, a type of static. Okay, the layer, or rather the tag for this. Okay, we can actually just call it a different name later. Okay, but the key thing is later when there's a the player, we will have to tag this as player so that we know like whether or not destroy the block. Okay, so this should be working right now. Right now we have created the walls for the game. Let's see how it looks like. Okay, so far so good. That's how the game looks like right now. Now what I want to do is to create a ball. So 2D sprites, a circle. Let's create a circle. Okay, why is the circle so weird? So we can go to transform and reset this position. Okay. Oh, I know why. I've created the circle inside the wall itself. So what I can do is I can go create a new circle here. Okay, then we have a circle like that. We add a component, rigid body 2D. Okay, this one we want it to have gravity. Okay, so we use dynamic. A kinematic you cannot control. I mean kinematic, alright, if I were to click play, okay, it is also supposed to not have gravity, yeah. But kinematic objects, the interaction is a little weird, so it's better. I mean, you want to use kinematic, okay, you should on this full kinematic collision so that you can have kinematic collisions allowed and kinematic static collisions allowed. Okay, but right now we use dynamic. Okay, dynamic is a easier way to handle gravity. So we already have a gravity over here, gravity scale of 1, and then the mass accordingly over here. So you can see what will happen right now. Oh, hang on a minute. So if we have a dynamic rigid body here, okay, this one is static. Okay, maybe we should use kinematic for this. Yeah, we could use kinematic for our walls. Okay, because it's not exactly scanning the collision right now. So we use kinematic. Okay, we update our prefab here. We go to our prefab, apply all. This update the prefabs in the prefab folder so that the walls, we update one, the second wall will automatically be updated as well to kinematic. So let's just make everything kinematic. Only the ball dynamic, which will allow gravity. Okay, so I'm supposed to have a way to have a collider. So, oh yes, I did not put the collider. That is why. Yes, actually, if I'm not wrong, the ground could be static. So we didn't put in the collider. So the collider 2D, this one we can use a box collider. So we can edit the collider here. It fits the box kind of perfectly here. So this is a box collider, which we use to grab the ball. Okay. So this is a box collider. I'm pretty sure I can use static actually. So let's change back to static. Okay. Just now it's because we didn't like do the collider. So here we also use a box collider. We can see how the box collider looks like. Yes, it's like that. Apply all. So when I click apply all here, should have a box collider as well. Okay, it looks good. Now let's see how the ball works. So we go back to the game itself. Ooh. Okay, this is interesting. Okay, the ball itself. Oh, it does not have a collider. A circle collider 2D over here. So this is why when you have rigid bodies, you should also have a collider here as well. So you can edit the collider. You see that this is the ball. Okay, so let us play now. And then if all goes well, we should be able to see that this will be trapped by the walls here. Okay, so this will be the starting position. Okay, uh, we will allow the player to only move left and right. Okay, so let us create a script for the movement. Okay, so we just call this script the, the player script. Okay, because you're controlling the main player from here. So in this player script, okay, in this player script, the class is player. And what we want to do here is we want to basically make the player move left and right. So there's a very cool way to do this. It's called input.getAxis. So this will return based on your axis, like horizontal, it returns left and right. Okay, and then it will be pinned to a value -1 to 1. So we know like how hard the user is pressing. So we can do this. Okay, void update. Okay, so input dot get axis. Okay, input dot get axis horizontal. Okay, okay, times player speed times time dot delta time. Okay, this will basically just tell us what is the amount of time elapsed, okay, since the last update function. Okay, so the Unity way of doing things is that they will have the start function, or actually before that, there's a awake function. So it will have a start function followed by the update uh, start function for all the classes you create. It will run through that first. Okay, followed by the update function. Okay, there's also a fixed update for physics and late update, which occurs after updates. But generally, the flow will be start, then updates. So in update, we get the axis. Okay, so this axis over here will be the translation. Okay, so we can do something like this. Floats translation equals to this. Okay, after that, we can translate along the axis. So over here in the circle itself, the axis we want to translate is actually the x-axis. So what we can do is like that. Okay, transform dot translate. Okay, this transform dot translate will automatically translate according to the object's transform itself. So transform dot translate. Okay, so translation 0 0. Okay, this will translate according to the object's x-axis over here. So this should be all the code we need. Let us put this code on the ball itself, and we hope that the ball can move left and right. Okay, first up, we can see some errors here already. Player speed does not exist. So here, let me introduce this thing called private variables and public variables. Okay, so in Unity, if you want the variable to be a private variable, okay, you just do the usual one, like float player speed equals to 1.0f, like that. Okay, but if you want it to be a public variable, you can just put the word public. Okay, this means that your variable will be editable in the um, it'll be editable, okay, in the inspector later. So if we do a public for this player speed, okay, let's just put this here. So let me just put this in the circle. Okay, so if we click on circle right now, okay, we will see that in the circle player script, we can have a player speed here, which we can edit. So there are a few ways to do this public variable. One is to do a public. The other way is to do this thing called serialized field. It both work. Okay, the advantage of serialized field is that it will appear in the inspector, but it's essentially still a private variable. Okay, so that other classes cannot edit it. So you can see that over here. If we use serialized field, you can still see it here. Okay, in general, I don't really use serialized field. I just make it public. Okay, there are advantages and disadvantages to all of this, but I mean, you just choose whatever you want to use. I prefer the public because to me it makes not much difference. Okay, and I save some time in typing less code. Okay, so let us see how it looks like now. So we have this ball, and we can make it move left and right like that. Okay, the movement speed for this ball is a little slow. Okay, and that's where we adjust our player speed. So our player speed, maybe I do 5. Okay, because we want the ball to be able to like avoid falling squares that come from above. Okay, let's see. Yeah, looks quite nice. It looks like it's lagging a little. Yeah, I don't quite like the feel of this actually. Uh, it feels like this. Maybe the player speed is a little too fast or something. Okay, but the input get key axis horizontal. Okay, feels like feels like it's a little like fast. I want it to just go similarly whenever I um like so basically I want to get axis horizontal that is not scaled based on like the amount of time I press. Okay, because in this game, we want it to be like instant reaction. Okay, so what we could do is like this. Okay, we could make this thing okay become -1 or +1. Okay, so we can do something like this. Floats x translate, or maybe you can just call it x x-axis maybe equals to input dot get axis horizontal. Okay, if it's greater than 0, okay, then it'll be 1. If not, it'll be -1. So I'm just like hard setting this axis, okay, to be either left or right, like that. Yeah, this is a ternary operation where you do a condition and then you get two outcomes. Okay, so let's see whether this code works. Okay, let's see whether is it smooth enough. Okay, so let's take a look. Okay, by default it seems to be like moving left. Okay, yeah, maybe if it's 0. Okay, you know what, actually we just do like that. If input dot get key down left, key code dot left, we could do this. Okay, then x-axis equals to -1. Else if input dot get key down, key code dot right. Okay, so if we press the left button then we go x-axis is -1. If we press the right button, our x-axis is +1. Okay, and when we do this whole thing here, okay, so unity key code for left. Okay, let's see what is it. So it's key code dot left arrow. Okay, we need an arrow here and right arrow. Okay, so that settles it. Okay, let's see whether it works. Okay, great. It looks like it's working. So let's take a look, see what's going on right now. Okay, it's moving, but really, really slowly. Okay, I want it to continue. Okay, even after it's down. So it may not be input dot get key down. It might be input dot get key. Okay, the moment when that key is pressed, okay, it will continue moving left and right. So let's see what will happen now if I do input dot get key. Okay, let's see. Nice. Okay, I think the ball might be a little too big. Okay, so let's scale it down a little. Okay, scale it down a little, maybe a scale of 0.5 in the x-axis, zero 0.5 in the y-axis. You can see right now how the ball looks like. Yeah, looks good. Okay, I mean, we can also make the ball have a little jump later. Okay, by applying a force on the rigid body. Still feels a little laggy though. Yeah, I need to get the feel of this right. Yeah, I'm not sure whether the lag is it caused by by the streaming. Because if the lag is caused by the streaming, then actually, uh, I think the initial method might be the easiest. Like we can like skip all this. Okay, we can just do input dot get axis horizontal, and actually this will be the easiest way to get this thing going. So yeah, we could do this. Let's see how the feel of the game feels like. All right. Yeah, I think this is good. Yeah, we don't really have to use whatever that was there. Okay. I mean, if you want the ball to jump, okay, we could also do apply force to rigid body. Okay, so we can do this rigid body dot add force. Okay, so we can do rigid body dot add force. Okay, transform dot up the m dot thrust. Okay, actually this code it's uh it's quite nice, right? Yeah, because basically this is based on the up button, which in this case could be the key code dot up. Okay, we could just copy and paste this whole code. Okay, and then we could add a force to the rigid body. So firstly, okay, in our private variables, we need to form a rigid body. Okay, my rigid body. Okay, so over here, what we need to do in the start component is that we need to make the rigid body is to find the component of the rigid body 2D. Okay, here is rigid body, but we should actually find the rigid body 2D component because this is a rigid body 2D. Okay, and then over here, check for jump. Okay, if input dot get key down, okay, and then this key will be key code dot up arrow. Okay, so up arrow is to jump. Okay, okay, then what we need to do is my rigid body dot, okay, let's go back to the code. My rigid body dot add force. Okay, transform dot up, which is the up position. Okay, or we can actually also do vector 3 dot up. Vector 3 dot up, which is the vector upwards. Okay, times thrust. Okay, so over here we can also have a public float thrust. Okay, equals to 5. Yeah, maybe we can allow this. Okay, let's see. Okay, so it looks like we just need get component rigid body. Yeah, okay, so now it's working. So the rigid body component can be accessed by just using the rigid body type. So let's see if we jump with the up button. Oh, there is no rigid body in the circle object. Okay, so actually it should be still rigid body 2D, right? Okay, let's take a look at this component in rigid body 2D properties. Okay, let's search Unity again. Rigid body 2D. Yeah, it's called rigid body 2D, isn't it? Oh, I know the problem because I declared this as rigid body. Yeah, so silly me. Yeah, it should be a rigid body 2D class. So the top part should be declared as rigid body 2D as well. Okay, so let us see right now how this is working. So if I do an up right now, okay, so this key code is working. Okay, it's just that because of this transform dot translates, okay, that that basically nullifies the force that you put onto your rigid body here. Okay, so perhaps instead of doing this transform.translate, okay, we can do again using the rigid body. Okay, add force. Okay, vector 3 dot right times translation. Okay, so we add a force to it, and then that force should last you for the duration of the entire period of the. Okay, let's see whether this works. Okay, there's something new as well. I never really coded this game before. So I press left and right. Okay, but there's an issue right now. You see, my ball isn't moving anymore. So after I added in the jump, okay, it appears that this rigid body dot add force, okay, did not work out. Okay, so yeah, I mean previously with transform.translate, it works. Okay, but once I use this rigid body add force, it didn't. So let's see the properties of the add force again. So apply a force to a rigid body. Okay, if you don't specify, the default would be force mode 2D, which add force over time using mass. I think it's fine, right? Yeah, because after I applied the force to the rigid body, okay, it somehow didn't register. I mean, initially I used transform.translates, which means that this will allow us to translate the ball, right? But right now, um, when I use rigid body, it sort of didn't work. Okay, so this is how I normally do for like games which involve jumping. Okay, you can use a rigid body to do the jump. Okay, let's just remove this whole part up here. Okay, this one we can delete this part. Let's just do the jump part. Okay, because I believe this actually should work. So let's see how it works now. Okay, it's not jumping. Okay, one way to check whether it's working is we can print here to see whether it's jumping like that. And then I see whether it's a problem with the get key down or it's a problem with the ball. Okay, let's take a look. Okay, yeah, so it is the rigid body itself that did not get the required amount of force. Okay, so rigid body dot add force. Yeah, I think maybe we should use like force mode 2D dot impulse maybe, which will probably add in a force like a triggered force as an instant force. Yeah, let's take a look, see whether adding this will help to solve this issue. Okay, so it appears that nothing is happening. So maybe it is because like the trust isn't enough. Maybe I set a trust to be 100. Oh, you see, it's moving now. Yeah. So it turns out that it's because the trust is not enough. Maybe 500. Yeah, this should actually work. Yeah. So okay, let's clear this. So the trust I set it to be 500. Oh, it flew to the sky, I think. That's my circle. It's still flying up. Yeah, 500 thrust is maybe too much. Okay, it overcame the gravity itself. Maybe a thrust of 50. See whether the thrust of 50 works. That's all if we want to create a jump option for the ball. Oh, look at that. Yeah, now it's working fine. Yeah, so now I go back to a thrust of 5. Okay, not sure why it didn't work just now, but this thrust will allow the ball to be pushed up. Yeah, yeah, this feels great. And then we can even make it such that only when it's touching the ground then we jump. Okay, but for now we allow it to double jump, triple jump, and so on. Okay, you can use something called is touching layers to determine whether to jump or not. Okay, so I think I can put back this code and it should still work. Okay, with this transform.translate. So let's take a look, see whether it's okay. Okay, because the transform.translate should take into account the object's current x and y position. Okay, let's take a look. Left, right, jump. Very nice. Okay, so I got myself a moving ball that can jump. Okay, it can jump triple times or more than that. Okay, I think I'll just let the user explore his own. I'm not going to restrict the jump. Okay, we're just going to let the user be able to jump as many times as they want, or the player, and then just let the bricks kill the player. Okay, so maybe what we need now is we need something to prevent the ball from going too far up. Okay, because if the ball goes too far up, then essentially the player could escape the game. You don't want to let the player escape the matrix, right? So we need a wall. Okay, we need a wall at the top. So we don't want just the side walls now. We want a wall at the top. Okay, so it's very simple to create a wall at the top. Let's duplicate this. Okay, and then we will just drag this thing here like that. Okay, and maybe shift it down a bit so that it appears within the camera itself. You see underneath that. Okay, so this is how it looks like in the game right now. Okay, so let's see. Yeah, okay, now you cannot escape the. Yes, okay, so it's quite a nice interface. So yeah, now let's program the falling bricks. Oh, where's my ball? Oh man, it clipped out of the wall. Wow, what a strong ball. Okay, apparently it managed to break out of the wall. So what we need to do is we need to have a thicker wall. Okay, so that it cannot get out that easily. Okay, so apparently the wall can be broken out. Interesting. Just gonna get the wall bigger. Okay, so that you know the player can't escape. We don't want the player to escape. So set the wall to be bigger. The one at the bottom don't need to because I don't think there's a way for the player to clip through that wall. Okay, let's just test whether it can clip through. Okay, looks good. Nice. Okay, so what's left now is to program the falling bricks. So how do we do the falling bricks? Okay, so it is very simple. Okay, the falling bricks, okay, should not be impacted by any of this. So the falling bricks actually do not need to have a rigid body. Okay, the falling bricks just need to have collider. Okay, and the moment the collider touches something, there's the player, then we should load this like game over message. So firstly, let us create the Yeah, shouldn't create a game object. Let's create a square. Okay, because this will be the following object. Okay, so we create a square, and then let's, oops. Okay, so this following object here, we will have a collider 2D, a box collider 2D. Okay, maybe this one we can set it to be like maybe red color. Yeah, maybe something like this. Okay, we still need a rigid body actually, because we want it to drop down with gravity. So something like this. Okay, let's see how it works now. Okay, so this will be our object. Okay, and we don't want it to like collide with, so we can actually go to file. Okay, build settings. Sorry, wrong one. Okay, we should go to edit project settings. Okay, then we can see the layer collision matrix here. Okay, we can add a new layer. Okay, that doesn't collide with anything else. Okay, so let's put a new layer for this. So we can call this bricks layer. Okay, so the bricks layer, okay, the rest of them are at layer defaults, but the bricks layer will just collide only with the player. So let's see. So where's my project settings? We have a bricks layer. Okay, so the bricks layer will not collide with anything except bricks. Okay, so let's see how this affects this brick movement. So oh, apparently it's colliding. Okay, it's supposed to not collide. Okay, with anything. Bricks only collide with bricks. Ah, like that. Okay, let's try again. Oh, that's because I didn't give it the layer bricks yet. Ah, there we go. You see that? The brick just fell through the ground without colliding the player. Okay, that's because it is on a separate layer. Okay, so we also can have another layer, okay, over here, called the player. Okay, which we will put to the circle. Okay, and this one we put to the bricks. This following object we can put under prefabs. Okay, so we put this here. Okay, so like that. Okay, what we will do is, let's see how the brick falls now. Whoa! See, it can collide with the player, but it won't collide. Okay, it won't collide with the walls. Okay, which is great. Okay, what this also means is that we need to have a separate wall at the bottom to catch those bricks that have fallen through the cracks, literally. So this ground itself, let's duplicate it. Okay, we just call it object destroyer. Okay, so this ground we can put it all the way at the bottom here. We stretch it out a bit. Okay, we're gonna have a script for this. Okay, destroyer. Okay, so any object that collides with this destroyer, we want to destroy it. Simple as that. Okay, so over here. Okay, so let's do the on collision enter 2D. So when two game objects collide, we can use this script. So on collision, enter 2D like this. So whenever you enter collision, okay, collider, okay, dot game object dot destroy. Okay, so I think we can just do this, destroy whatever it is on the collision 2D. So this collision 2D itself has a property called game object. So we can destroy the game object involved in the collision like that. Okay, let us put this script, okay, on the object destroyer. Okay, so we can see this in action. Okay, we can see this in action as the square falls through. So let's see. The square should fall through this and get destroyed by this. Okay, so just now what you saw is that it didn't get destroyed because this object destroyer is not in the bricks layer. So let's put this in the bricks layer. Okay, so let's take a look now. Okay, so it is supposed to fall, and the moment it lands here, it's supposed to be destroyed. There we go. Object gets destroyed. Okay, so right now, if you look at the gameplay itself, you will see that there's a square. Okay, whenever the square goes down, hits the circle, okay, you would die. Okay, let's see. Okay, something is wrong with my forces. Upon hitting the square, the rigid body goes haywire. Okay, so this wouldn't be an issue actually. Okay, because the moment when we hit the square, actually the game will restart. So not a big issue with that. See, after it hit the square, it moves off in its own world because of the effects of the collision. Okay, so the reason why in this project settings we set the bricks to only hit the bricks and the player, okay, is quite important. Okay, it's because we want the player to be able to get killed by the bricks. Okay, but we don't want the bricks to get killed by each other. Sorry, we don't want the uh, we also want the player, okay, to be able to be stopped by these walls here, which are in general in the layer default. So by setting our player, our circle, okay, to be a layer player, which is interactable with this bricks layer, okay, we can then ensure that whenever this player collides with the object, okay, we will like sort of destroy the object. Okay, so how do we know whether this brick itself hits a player or not? Okay, so this is where the collision needs to come in. So we have a destroyer here already. Okay, on the circle itself, okay, we need to have, okay, a determinant whether the circle collides with the falling object of the wall itself. So we use this thing called tags. Okay, so we add a tag over here. Okay, and over here we add a tag called bricks. All right, so in our circle itself, okay, if we collide with the collider.tag, okay, so in the collider itself, okay, in the game object, I believe there's a tag. Okay, so collider 2D game object tag. Okay, so we can actually check the collider, okay, tag. Okay, okay, this is a bad script, but basically with the tag we can check whether, okay, the player dies or not. So over here, okay, in this case our player is also our game manager because this is a very simple game. So the player itself will control the logic for the game already. So let us see, okay, when the player hits a square, okay, then or hits a brick, then reset the game. Okay, as simple as that. So when the player hits the brick, we reset the game. So what we can do now is we can do this. Okay, we can do on collision enter 2D. Okay, similar to this script here. Let's copy and paste this code here. Void collision enter 2D, collision 2D collider. Okay, if collider dot other dot collider dot game objects dot tag is the same as bricks. Okay, they are label it brick or bricks. Let's see. They call it brick or bricks. Bricks. Brick. Yeah. Okay. We destroy the brick. Okay. Print game over. Okay. Then that will be it. We can actually also restart the game itself. Okay. I will show you how to do it soon. Okay. We can then print this game over, which will basically mean that we will see a game over message here. Okay, for now that's what we can do. Okay, so this is what we have so far. Let's click play. Oh, see, game over. Okay, and I also like to reset all the rigid body when it's game over. So how to do this? Reset forces on rigid body 2D. I guess if not, it will how to reset or erase the force. Okay, so rigid body dot velocity equals to vector 3.0. Okay, my rigid body dot velocity equals to vector 3.0 zero, right? Yeah, exactly. Which will then basically reset the velocity to 0, and then it won't it won't have this awkward movement anymore. So let us take a look. Okay, still kind of affected by it. Ah, I have an idea. Okay, what if what if the object itself, okay, the box collider is a trigger. Okay, then it should be okay already. It wouldn't affect the ball itself. So let's take a look. Okay, yeah, no, this won't do. Okay, because the moment I make this a trigger, okay, it also pass through the object destroyer. Okay, unless I do an object on trigger, uh, enter 2D. Like this. You can do a on trigger enter 2D. Yeah, then actually this doesn't we don't really need this game object as break because we will never. Okay, so whenever we enter a trigger, okay, it will it will destroy the game object. Okay, it must be a collider 2D instead of a collision 2D. Okay, no worries. Yeah, so basically we set the break to be a trigger. Okay, the moment down here, up here it enters the either the kill zone or the player itself, it will If it enters the player, okay, we will just print game over. Okay, but if it enters the bottom, we will print, we will see that the object will be destroyed. Yeah, so it's working as planned. Okay, and the benefit of doing this is that the ball itself won't get killed, won't get hit by the object and have weird forces acting on it. Okay, it will still be able to move normally after you like reach the game over scene. Okay, the downside is that we won't be able to see the ball getting hit by the brick. So there's pros and cons for both methods. Okay, so right now, what I like to do is I like to do the scene itself. So we want to do a reset game here. So we can do this thing called start coroutine. Okay, reset game. Okay, and what this reset game will do, this reset game, it will be an I enumerator, which will basically start a separate thread, okay, to run the reset. Okay, so we need to use this thing called scene manager. Okay, scene management. Okay, so what we can do is we can do this scene manager dot load scene. Okay, reload active scene unity. I believe it's get load scene. Okay, scene manager dot get active scene. Okay, and that's right. Yeah, so we'll reset the game. Okay, but before that we'll wait for maybe 1 second before we reload the game. Okay, so if we are doing this, actually we can just continue to keep this as a on collision enter 2D. Yeah, let's keep it as collision. I kind of like the effects of the collision. Okay, I mean, a few days later when I'll teach that time, I'll also use collisions. Okay, collisions seem better. Okay, so let's take out the trigger. Okay, uh, argument 1 cannot convert from method group to string. What is this? 49. I think it's something like build index. Yeah, that is. Yeah, yeah, this is what I remember. Yeah, so we can load the scene here using this I enumerator. Let's see. So it will wait for 1 second in the separate thread, and then it will reload the scene again. Okay, so this is a collision 2D. This is a collision 2D as well. Okay, all's looking good. Okay, all's looking good. So let us see what we can do with this right now. Okay, let's take a look at the game right now. Game over. See, once game over, we reload the scene. But before that, you can still avoid the bricks. Let's try again. Nice. Okay, so you will see a movement about 1 second, and then you just keep avoiding the bricks like that. Okay, so now okay, before we go into scores and everything, what we want to do next is we want to have multiple bricks spawn, okay, at random intervals, okay, and then keep falling down on the player. Okay, so how do we do this? So we do have a falling object over here, okay. So what we can do is, okay, this falling object is a prefab, okay. What we want to do next, okay, is we want to have multiple, okay, let's not call this a falling object, but we call this a placeholder for the falling object. So I'm just going to duplicate this. So I will call this a falling object placeholder or falling object spawner. Okay, so we want to create a spawner. Okay, let's unpack prefab completely. Okay, which means we won't affect the prefab itself. I'm going to remove. Okay, actually there's no script on the prefab, so it's fine. So this sprite renderer, okay, will just be there to show us where the sprite is. Okay, so I mean but eventually when we make our game active, okay, we don't want to see this. We can set this thing to be unchecked like that. So we have a sprite falling object spawner. Let us create a script for it. Okay, so C# script spawner. Okay, so this spawner is quite simple. Okay, what we want to do is we want to spawn a game object, okay, at a regular interval. So as usual, let us do a spawn interval. Okay, okay, maybe we have a spawn min interval and a spawn max interval. Okay, maybe 2 to 5, perhaps 2 seconds to 5 seconds, it will spawn something. Okay, or maybe 1 to 3. You can change this. Okay, let's set it to public so that you can change this parameters for. Okay, and then we also have another one, public game object break. Okay, which will spawn the break. So we do have some private variables here also. Floats time equals 0. Okay, so over here what we do is time. Okay, if time smaller or equals to 0. Okay, so we just minus off the time. Okay, we will spawn the game object here. So how do we spawn the game object? Okay, we can how to instantiate this. Okay, instantiate a certain prefab, spawn position. Okay, and then the identity. So we can instantiate. Okay, actually we can just instantiate break. Okay, let's just call this break prefab. Transform.position. And actually that should be it. Okay, because if we were to do this instantiate thing, okay, we will be able to instantiate the prefab, okay, at the position itself. Transform parent. Actually, this is what we should use. The original plus a position, and sorry, when we don't want to put under transform parent, we do it under position and the quaternion rotation, which is quaternion.identity. There we go. And that's how we spawn the game object. Okay, and then we set a time interval. Okay, so when we start the time, we will have this time equals to random.range spawn min interval spawn max interval. Okay, and then we can actually do the same thing here also. Then we can reset timer. Okay, so this will be our spawner class. Let's see whether there's any errors. Okay, does not contain a definition for identity. Did I copy it wrongly? Oh, it's a small letter I over here. So we change this to small letter I. Let's see how it goes. Okay, let's see how it goes. Okay, so now we have this. Okay, let's put the spawner on this. Okay, the spawner script is here. Let's make this a prefab. Okay, right now, okay, I'm gonna delete this falling game object. Okay, because in the prefab itself, the spawner itself, the break prefab, I'm just gonna put the falling object here. Okay, so when we see here, this break prefab has already loaded the falling object. Okay, so far it's at this position. Let us see now whether the bricks really do fall down. So we should have this brick spawning at regular intervals of 1 to 3 seconds. So it looks like it's working. Okay, so right now we have this falling object spawner. Okay, with a current sprite renderer now to just show us the position of it. Okay, let us just you know, copy and paste this at regular intervals. So okay, I mean one easy way to do this is to go by intervals of, let's say, okay, this is at height 4 minus 7. Yeah, so maybe we can do 1 here at minus 7. Okay, and then we can, like, you know, duplicate this and then cover like separately one by one. Minus 6, minus 5. This should be good because the intervals are exactly 1 apart. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, of course we can do this through script also, but it's easier to do this like manually like that, so that you can see for yourself. Like, okay, now we have spread across the entire thing. Okay, let us just disable this sprite renderer and apply all. Okay, so in the main prefab itself, we can see that the entire top row has been gone. Whoa, 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 whoa. That's a little crazy, right? Why is it not resetting? Okay, so apparently there's this reset thing that is not resetting. So if we were to reset, look at that. Oh, it's actually quite tough, man. Okay, it's not resetting right now, but the idea is there. Yeah. Okay, I also think that the spawner itself, perhaps maybe we do 3 to 5, or maybe 1 to 5. Yeah, because right now it's spawning a little too quickly. So let's apply all. Now it's going to be 1 to 5 for the spawning. Yeah, let's see how it looks like. So yeah, looks pretty good, isn't it? The spawner. Whoa, look at that. It's actually pretty hard to avoid. Okay, so once the ball dies, okay, apparently it's not loading the, okay, when the player gets hit by a brick. I'm not printing this anymore. If collider.gameObject.tag equals to break. Okay, so why am I not printing this anymore? Oh, okay, because the following object is not tagged as break. Okay, simple fix. Now if we go back to the game, we should see the game resetting whenever we get hit by the break. Yeah, feels good enough, I think. Right. Yeah, I think this pace is actually quite good for the game. It's challenging enough. And I guess as the level gets harder, you could increase the spawn interval, but not gonna do that right now. Right now I think this is it's pretty tough already for someone to to play this game. Yeah, wow, you need to like think ahead in advance to avoid. It's like avoiding the bullets. Yeah, it's like, oh, I hit. Okay, so what we can do next, okay, is we can have a simple UI for the game. Okay, so we could do something like in this canvas itself. Okay, we could do something like score. Okay, score is how much. So the canvas itself. Okay, let's just put this. We don't want to. We can do this in world space, and we put this in the main camera. Okay, screen space. Let's do it in screen space. Okay, so this will be the same space as our game itself. So our text is here. Okay, let's expand this text. Okay, the font itself we use Arial, no problem. I mean, it's just a tutorial. Okay, we use Arial here. Maybe the font size 100. Okay, can I see anything? Okay, maybe I put best fit. There we go, best fit. So over here is called XXX. Okay, so we can see how big this score will appear. Okay, if we were to play this game. Okay, so now what we need to do next is we need to set a way to let this score be like running in real time whenever the bricks fall down. Okay, we want to set the score to be running in real time. Okay, it's actually quite tough. This game is pretty fun also actually. Okay, so we need to set a way for the score to be updated in real time, and then like maybe a game over message to be displayed when we die. Okay, so let's do another thing called game over message. So here will be game over. This one we can set the position to be in the center. Okay, like that. Okay, maybe the color can be a little different. The color can be maybe yellow, I think. FFFF00. See how it looks like. I think the white score is okay. Yeah. Okay, so right now, maybe the score text is a little big, like this. Okay. So in the player itself, this will also be our the main menu itself. Sorry, the main scripting for the code for the game logic. So we can use Unity engine.ui, which will contain all the stuff like all your text. You can control your text stuff using Unity engine.ui. Okay, so over here, what we can do is we can then change like what will appear here. So maybe at the start, we can have a private variable. Okay, and then this will be score. Okay, so at the start, okay, set score to 0. So score equals 0. That's all. So every time we do an update, okay, okay, so we have a date also. So here we set date to be false. Okay, if not date, we increment our score. Okay, and then we also display this score. So we need to find, okay, over here in the public. Okay, we'll have a public. Okay, text score text. Okay, and we also have a public text, game over text. Okay, and over here, we can do this at the start. Game over text dot set active to be false. Or actually, what we can do is simple. Just don't display any text. Okay. Uh, we can have a function called display score. Okay, what display score would do is like that. Void display score. Okay. Score text dot text equals to, I forgot that you need a dot text here to equals to, okay, score dot to string. Okay, we can just do like score plus like that. Yeah, so this will display the text with underscore text. And now let's go see the player itself. Okay, number 44. Oh, this is a semicolon. Okay, so this should be it. Okay, let's go to our player, which is currently the circle. This is called this the player. Okay, and then in the player itself, we should have a score text and a game text. So let's just label this score text. Okay, so in the player itself, we should put our score text in here, and we should put our game over text in here. Okay, and also when we die, we also need to, in the reset game maybe, okay, score text, so game over text dot text. Yeah, we could do this so that we will display the game over text whenever we die. So I think that should be it for the game. Let us see whether it's working. So yeah, this took a little longer than I expected, but this should be a working game. Ta-da! Yeah, we can even set that the intensity of the game will increase based on the score itself. Actually, why not? Let's do that. Okay, let me just kill myself first. Oh, game over. Okay, wait, there's something wrong here. And game over, my score should not increase anymore. So I forgot to set one variable here. Okay, date equals to true. I mean, the bricks can still spawn, but we don't want the score to continue rising, right? It won't be very fair to the player if we have the score rising, right? So let's see. So we are avoiding all these bricks one by one. Oh, and game over. How's this? Oh, looks pretty good actually. So we have a score like that. Okay, let's make the game get harder and harder. Okay, as the score increases. So how do we do this? So over here, very simple. We have a spawner, right? Okay, so basically the spawner would be the same time as the player's score. So what we can actually do is this. Okay, we can have this. So over here we also can update the score as it increases. Okay, and then over here in the spawn max interval here, okay, we can actually have this interval. Okay, okay, we call it buffer time. Okay, okay, so our buffer time maybe, Yeah, so maybe we could have this. So as to increase the buffer time. So that means at first the interval is between, say, 1 second to 10 second. Okay, the buffer time. So over here dot random dot range plus buffer time. Yeah, so that this will, so basically the buffer time as the game goes on. Okay, the buffer time will be decreased. Okay, until it reaches zero. Okay, then it will affect the max spawn interval. Okay, let's see what happens. Okay, so we have this float called buffer time. So the more the game goes on, the faster the bricks will spawn and faster it will go down. Okay, let's take a look at how it goes. Okay, so initially still looks okay, right? It looks pretty manageable. Then after a while, it degenerates into hell. Okay, when uh, when the buffer time goes to zero, which basically it's about the score 5,000, you will see the madness ensuing. Yeah, so this is the interval between 1 and 5. Oh, yeah, I touched something. Yeah, so anyway, this is more or less it. Can probably show how to add in the music as well, which is just a simple dumping of the music into here, and then we will have some music. Yeah, but I think I'll leave that for another time. I've got to go already. So there we go, a simple brick evading game. Actually, I might just refine this a little more, and then it could be quite fun actually, this game. Yeah, so you can see that the bricks itself, they start off slow, and then initially after they reach about 5 seconds, it becomes unplayable. Becomes hell actually. Yeah, I mean, if you want to make it even harder, at the side of the screen, we could have little lasers that can shoot from left to right, and then basically the laser will appear after a certain animation. Okay, and then once you get hit by the laser, you die as well. Yeah, so you not need to avoid the breaks at the top. You also need to avoid the stuff at the side, which adds a different scope of challenge to the player. Because you can jump, right? So make full use of the jump ability and challenge the player to avoid those lasers at the side as well. So these are some stuff you can do with Unity. Quite cool as a game engine. And yeah, I hope you've enjoyed this video. And that's it. Alright, let me just get a game over. Oh, game over. Alright, and thank you. And yeah.